Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about permutations and combinations. When you work with permutations and combinations, there are formulas involved, and we're going to get to those formulas, but what I want to do is approach this from more of a logical point of view, and I want you to visualize it. And the way we're going to do that is by using Skittles. Let's start off by talking about what a combination is and what a permutation is. A combination is a group, and because it's just a group of select items, the order is not important. A permutation, on the other hand, is an arrangement, and because it's an arrangement of a group of items, the order is important. So let's take a look at three different colored Skittles: red, green, and yellow. If we look at how many combinations we can have of those three Skittles as opposed to permutations, with combinations it's just a group, the order doesn't matter, so we only have one group of three Skittles. However, if we take a look at permutations, we can order them red, green, yellow, green, red, yellow, yellow, green, red, green, yellow, red, yellow, red, green, red, yellow, green. So each one of these arrangements is distinct from the other. So there are actually 6 permutations of those 3 Skittles. You will always have more permutations than combinations. Now let's take a look at choosing 2 Skittles out of the 3 colors. And if we wanted to know how many combinations or groups we could make a group of red and green, a group of yellow and green, a group of yellow and red. The order doesn't matter, so we just have 3 groups or combinations. However, if we look at permutations, we have one arrangement that's red-green and another one that's green-red. So that gives us 2, yellow-green, green-yellow, 3, 4, yellow-red, red-yellow. So each of those is separate because the order is different. So we actually have 6 permutations when we choose 2 Skittles out of 3. Different colored ones, and we have 3 combinations. I'm sure you can appreciate that as our numbers get larger, this method of finding combinations and permutations is not very effective. It's going to be impossible because the numbers get so large. So let's take a look at what we use for formulas for combinations and permutations. We're going to start with permutations, and before I get to the formula for permutations, I'm going to show you another method that you can use called the multiplication principle. And I find that easier than actually using the formula, but you can choose what you prefer. Remember, permutations are arrangements, so the order is important. So if we take a look at our Skittle example, we have 3 different colors. And if I want to know how many different arrangements of 3 Skittles are there from those 3 different colors, what I can do is set up a multiplication. So for the first Skittle, I have 3 to choose from, so there's 3. I multiply that by the number of choices I have for the second Skittle. Once I've chosen one Skittle, there are 2 left to choose for the middle position. And then the last place, or the last Skittle, once I've chosen the first 2 Skittles, there's only 1 choice left for the last one. So when I multiply these numbers, I get 6 choices or 6 possibilities. And that's what we found when we laid them out. There were 6 permutations of the 3 Skittles. We can make one small change if we're only going to select 2 Skittles out of the 3 colors. How many arrangements or permutations are there? Well, for the first Skittle, there's still 3 choices. The second Skittle, once one's chosen, there's 2 left, and there's no third Skittle. But we also have 6 permutations when we choose 2 out of 3 Skittles. Now let's increase the number of Skittles. Let's say that we have 6 different colored Skittles, and we want to know how many arrangements would we have if we chose 4 out of those 6. We have 4 Skittles that we're choosing. So what we're going to do is put numbers in here that indicate how many we have to choose from. So for our first Skittle, we have all 6 to choose from. Then the next Skittle, I've chosen 1 for this position, so now I only have 5 to choose from here. Next, I would only have 4 to choose from because I've already chosen 2. Now that I've chosen 3 out of the 6, there's only 3 left to choose from for this 4th position. So that's the number of arrangements or permutations. So we have 360 different possible arrangements. It doesn't matter what our numbers are. Let's say we have 20 different colors of Skittles, and I'm going to choose 5. I want to know how many different arrangements are there of 5 out of those 20. So I'm going to indicate my 5 Skittles. So my first choice, if there are 20 to choose from, I put 20 here. Once I've chosen the first Skittle, I only have 19 to choose from for my second one, then 18, then 17, then 16. When I multiply all of those numbers, I get 1,860,480 possible permutations or arrangements of those 5 Skittles out of 20. Let's now look at the actual formula for doing permutations. So the formula looks like this, NPR, where N represents the number of items to choose from, and R represents the number of items chosen. The formula involves factorials, which I discussed in the last video, so if you're not familiar with factorials, I strongly recommend you take a look at that video. But this is defined as N factorial divided by N minus R factorial. So let's take a look at our last examples. If I want to choose 3 Skittles out of 3, I want to know how many different arrangements there are. That will be equal to N factorial over N minus R factorial. Zero factorial is not equal to 0, it's actually equal to 1. It's a special case of factorials. So 3 factorial will be 3 times 2 times 1 divided by 1, which is 6. Let's try the example where we were choosing 2 Skittles out of 3. So that's going to be N factorial over N minus R factorial, which is 1 factorial. 3 factorial we know is 6. 1 factorial is 1. So 6 divided by 1 is 6. Let's try the example where we were choosing 4 Skittles out of a total of 6. So according to my formula, that will be 6 factorial over 6 minus 4 factorial, which is 6 factorial over 2 factorial. So that's going to be equal to 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. 2 times 1 will cancel, numerator and denominator, and then we're left with 6 times 5 times 4 times 3, which is 360. And remember, that's actually how I did it using the multiplication principle. Let's take a look at choosing 5 out of 20. How many different arrangements are there? It would be 20 factorial divided by 20 minus 5 factorial. That's going to be 20 factorial over 15 factorial. So 20 factorial is 20 times 19 times 18 times 17 times 16. Now because I have 15 factorial in my denominator, instead of continuing 15 times 14 times 13 and so on, I'm going to write that as 15 factorial. Leave this as 15 factorial, and that allows me to cancel it in numerator and denominator, and then I can multiply those out to get 1,860,480. Now if we take that away, remember that's what we had when we were using that multiplication principle. So you can either use the formula or just use the multiplication principle. Let's now take a look at combinations. Combination is a group, not an arrangement, therefore the order is not important. You're always going to have fewer combinations than you are permutations. The notation for combinations looks like this, NCR, where N represents the number of items to choose from, R represents the number of items chosen, and it will be N factorial over N minus R factorial times R factorial. So let's take a look at some examples. We did the Skittle one where we wanted to know how many groups of 3 Skittles out of 3 Skittles we would have. According to this formula, we would have 3 factorial over 3 minus 3 factorial over r factorial. So n is 3, r is 3. 3 factorial, I'm just going to leave that as 3 factorial. 3 minus 3 is 0 factorial times 3 factorial. 0 factorial is a 1, so I'm going to have 3 factorial divided by 3 factorial, which was 1. And that's consistent with what we found. There was only one way to have a group of 3 Skittles out of 3 Skittles. What if we want to know how many groups of 2 Skittles out of the 3 Skittles we could have? Plugging into our formula will be 3 factorial divided by 3 minus 2 factorial divided by 2 factorial. That's equal to 3 factorial over 1 factorial times 2 factorial. Let's write that out. 3 factorial means 3 times 2. We can write times 1. It's not necessary. 1 factorial is just a 1. 2 factorial is 2 times 1. We don't need to write the times 1. We can cancel the 2's. So there are 3 possible groups of 2 Skittles out of 3, which again is consistent with what we did when we laid the Skittles out. One thing I want to point out with this formula, it's almost the same as permutation. If we were to remove this factorial in the denominator, that's our formula for permutation. So in other words, we take our formula for permutation, and then in the denominator, or in other words, we divide by r factorial. Let's find out how many groups of 4 we would have if we had 6 different Skittles. So our formula says it will be 6 factorial over n minus r, so 6 minus 4 factorial, and also in the denominator is 4 factorial. 6 minus 4 is 2. Now in the denominator, 4 factorial is the largest one, so I'm going to break this down until I get 4 factorial. So 6 factorial will be 6 times 5 times 4 factorial. 2 factorial is just a 2, and I'm going to leave that as 4 factorial because I can cancel that. I could also cancel a 2. So the number of groups or combinations will be 3 times 5, which is 15. Another way to think of it is when we did this as permutations, we got 360 permutations, which is this value right here. So if we took 360 permutations and divided by r factorial, we would get 15 that way. So just an observation of the relationship that you might find useful. Lastly, let's look at how many groups of 5 we have out of 20 distinct items. Plug into my formula, 20 factorial over 20 minus 5 factorial times 5 factorial. 20 minus 5 is 15. This is the largest factorial in the denominator. So when I expand this, I'm going to stop when I get to 15. So this will be 20 times 19 times 18 times 17 times 16 times 15 factorial. And I'm going to expand 5 factorial, 5 times 4 times 3 times 2. I don't need to put the times 1. I'm going to cancel the 15 factorial, and I'm going to do a little bit more canceling before I actually do the calculations. 5 times 4 is 20. That goes into 20. And then I have 3 goes into there once, and 3 goes into there 6 times. Then I have 2, which goes into there once, goes into there 3 times. So now I'm just going to multiply 19 times 3 times 17 times 16, and my answer is 15,504. Now if we would have taken the permutations, remember that value was over 1 million, and if we would have divided by 5 factorial, we could have found the answer that way as well. So a little bit of a shortcut. So these are the formulas for permutations and combinations, but students typically have problems of knowing which formula to use when is repetition allowed, and so on. So in my next video, I'm going to take a look at some typical permutation and combination problems that you may encounter.